Today we're going to do an activity on cladistics. A cladogram is a diagram that shows the evolutionary relationships among a group of organisms. So if we look at this group of organisms down here and find some derived characteristics that they share or do not share, we can see from the 4 species that mosses are the only ones that don't have vascular tissue. They are the outgroup. They are my originator here. So everything above this branch on the cladogram has vascular tissue. Ferns, conifers, flowering plants have vascular tissue. Now after that, conifers and flowering plants have seeds, whereas ferns do not. So that's my next branch. Everything above this branch will produce seeds, and then the last branch there, flowering plants, will produce flowers where conifers do not. So the derived characteristics are on my cladogram. Everything above that branch of the cladogram has that characteristic. So it allows us to group organisms that are more closely related, closer to their common ancestor. So what we're going to do is use an imaginary insect called a cladisticule based on some derived characteristics that we observe. So one purpose of a cladogram is to put a group of similar organisms in the order in which they evolved from a common ancestor. When we create a cladogram, that's known as cladistics. That root word clad means a group of organisms that share a common ancestor. So a cladogram is like an evolutionary tree. The species that are more closely related share more derived characteristics. So we had a cladogram in our notes, if you remember. The derived characteristics were listed between the nodes. The nodes are just simply where there's 2 branches that come off of our cladogram. A derived characteristic is a trait that can be used to determine the evolutionary relationships between a species. So anything above this derived characteristic on my cladogram here has lungs. Salamanders, lizards, tigers, gorillas, humans have lungs. Sharks and lampreys do not. So it's a way to use traits or features to organize species by how closely related they are evolutionarily. Okay, so these are our cladisticules. We're going to first write down the derived characteristics that we observe on our cladisticules and then use that information to construct a cladogram of our little imaginary insects. So the first thing we want to do is fill out our data table. We'll do a couple together and then you have the rest on your own. Let's start with Joe, our outgrouping, our original cladisticule. So if we look at Joe, does Joe's head fuse to his thorax? Yes, it does. His head is fused to the thorax. Do Joe's feet have 2 toes or 3? Joe's feet have 2 toes. Does Joe have 4 or 6 legs? Joe has 4 legs. Does Joe have antennae? Okay, antennae are those little googly eye things. No, he does not have antennae. Does Joe have horns? No, Joe does not have horns. Does Joe have a white thorax or an hourglass thorax? Joe has a white thorax. Joe also has a white abdomen. Let's also do Tanya. Tanya's head is not fused to her thorax. Tanya has 3 toes on each of her feet. She has 6 legs. Tanya has some antennae there. No horns, because she has antennae. Thorax has an hourglass shape on it. And Tanya's abdomen is black. This is where you need to pause the video and fill out the data table for the rest of the cladisticules. When you have your data table completely filled out, come on back to the video, press play, and we'll continue talking about the lab. Compare your data table to mine. Make sure we have the same characteristics for each of our cladisticules before we start to talk about our cladogram. Okay, now I will point out here before we get started with the cladogram that the only difference between Joe, the outgroup there, and the rest of the cladisticules is the fact that Joe has his head fused to his thorax. The rest of them do not. Let's keep that in mind as we start our cladogram. We're going to use the derived characteristics in that table to start filling out the cladogram. We're going to move our cladisticules onto the correct branch, and we're also going to label the space between each node with the derived characteristic that is shared by all the cladisticules above that feature. probably best if we do a couple together. So we start with the original guy. That's Joe. Joe's at the bottom of our cladogram. Remember, the only thing that was different about Joe and the rest of the cladisticules was that he had his head fused to the thorax. All the other cladisticules do not have their head fused to the thorax. So that is the characteristic that separates Joe from the rest of the cladisticules. So all the other insects are going to have a head that's not fused to the thorax. So now we need to figure out which cladisticule is most similar to Joe. So if you look at your cladisticules, you might say, well, you got Bobby and Jason and Mike. They kind of look like Joe. And when you look a little closer, you'll notice, well, Bobby is exactly the same as Joe, only his head is not fused to his thorax. In fact, when you go back to the data table, you'll see the only difference between Joe and Bobby is that Bobby's head is not fused to his thorax. Everything else about Bobby is exactly the same. They are the most closely related. So the next cladisticule on my cladogram will be Bobby. So now I want to look and see what's the next feature that will allow me to separate the rest of the cladisticules from Bobby. You might look, you go, okay, Bobby has 4 legs, and I got April and Jane that also have 4 legs. Okay, but they have 3 toes. Okay, I got Jason and Mike that kind of look like Bobby, but they got 6 legs and 3 toes. Okay, maybe it's the legs I need to do next. If you look at the data table, the difference between April and Jane when compared to Bobby is that they have 3 toes and they have black abdomens. Otherwise, they're exactly like Bobby. So should I use 3 toes or a black abdomen as my next derived characteristic? Well, I gotta use 3 toes because that's the feature all the other cladisticules have in common above that. Not all the other cladisticules are gonna have a black abdomen. So the next feature I'm gonna use is 3 toes. All of the cladisticules above this point are gonna have 3 toes. They're not necessarily going to have a black abdomen, so I better use 3 toes, not a black abdomen. All right, this is where I leave you. So you need to finish the cladogram, placing the cladisticules in the right spot, and make sure you label the spot between each node with a derived characteristic. I will say there's one derived characteristic on your data table you're not going to use. Put a little bit of thought into this. I know you can do it. Good luck.